mortality rate and the average number of televisions per capita, so that's TVs per 1,000 people, was found to be R equals negative 0.84. So explain what that means in your own words. So what we're looking at are two variables. We have the infant mortality rate and the average number of TVs in the country. And that has a correlation that's negative, and it's fairly strong. And we know it's strong because it's close to -1, okay? So there's a strong negative linear correlation. So you're looking for whether or not it's strong or weak. If we had a smaller number, it would be weak if it was closer to 0. And whether it's positive or negative, and we want to use the word linear. Okay, so strong, negative, linear correlation. Now, this is saying that the infant mortality rate goes up if the number of TVs go down in the country, or the opposite, the infant mortality rate goes down as the average number of TVs goes up in the country. There is a strong correlation, doesn't mean one causes another. So B, does it suggest that if people own more TVs, then the infant mortality rate will decrease? So does that mean if the country buys everybody one more TV, we're going to have a lower infant mortality rate? And no, because correlation does not mean cause and effect. It doesn't mean that one thing causes another. It just means they are both correlated together. So part C, explain your reasoning and suggest a possible lurking variable that may play a role. Well, do you think people buying more TVs is going to make for healthier babies? Probably not. But why do you think people might be able to buy more TVs and that causes healthier babies? Well, it could be that a country that has more TVs means several things. It could mean better infrastructure, larger houses, so that disease wouldn't spread as easily. It could mean that people have higher income if they can afford more TVs. They could have better access to healthcare because of that higher income. So it might be more of a money issue, and that more TVs and lower infant mortality both are related to money. Let's go on to the next question. So for this problem, we're going to use a StatCrunch file, Apartments in Queens, New York City, Chapter 4 Classwork. So it's going to be in the class data set, and you can just search in all the data sets. And it's apartment data for Queens, Chapter 4, test number 3. So I'm going to go and grab the data, and we can look at it together. Okay, so here we are in StatCrunch, and I'm going to load the new data from my groups. And our group is the one with the pie chart. And if I go down, it's probably towards the bottom because it's pretty new data. And there it is, the picture of the house, the apartment building. So here is the data. It has square footage. I'm going to pull that over a little. Square footage for apartments and the rent per month in Queens, New York City. So now I'm going to go back and look at what do we need for that. So it says the data represents the square footage and monthly rent for apartments in Queens and New York City. Include a scatter plot using the square footage as the explanatory variable. So they want us to do a scatter plot with square footage as an explanatory variable. So if I go back in there, here's the data. I'm going to do stat, regression, simple linear. My explanatory variable or my X variable is square footage, and my Y is rent, and I compute. So if I'm going to look at the scatter plot, I'm going to use the little arrow at the bottom right, and that will get me the scatter plot. In order to grab it, I click on Options and Copy. And then I can right-click it and save it either in a file, or I can just put it in a Word file to paste it, however you want to do it. Okay, so you can copy the image, or you can save it as a file to upload it. So if we look at the graph, it looks like we have a pretty strong linear correlation because it's all lining up on that line really nicely. So we'll go to the next question. Determine the linear correlation coefficient. So if I go back to StatCrunch, I do stat and regression. Where is it? There it is. Regression, simple linear. X was my square footage, Y was my rent, and compute. And I get my correlation coefficient right here under my sample size of 11 as 0.9686. So if I round that, it would be 0.969. So my correlation coefficient is R equals 0.969. So here we have a strong positive linear correlation. So that means as the square footage of an apartment goes up, we would expect the rent to go up. That makes sense. So now you want to compare it to the table, the significance table, to see if the correlation is significant at the alpha equals 0.05 level. So we have 0.969, and we had n equals 12, and R was 0.969. So we just have to be higher than what it says on that chart. And if I go back to that chart, I'm going to go back to where the chart is. It's kind of hard to see, so I'll go in here. Let me get rid of my writing. And if I look at where we have 12, then significance is 0.576. So we're definitely higher than that. So we can say that we have significant correlation. So going back to our assignment, we definitely have a significant correlation because R was greater than I forget what the number was. Go back. The number for 12 was 0.576. So R is greater than 0.576. So it is a significant correlation. So that